Hello guys, this lecture is about the application of Bayes' theorem. So before we move on to this, a basic understanding of conditional probability is quite important, wherein the concept is that for an event A, suppose if there are two events A and B, then the probability of event A occurring given that B has already occurred is given by P A intersection B upon PB, where A is always the subset of B. Alright, let's say for an example that a dice is being rolled and I already know that the outcome is an even number. So what is the probability that it is 2? Alright, then it is given by, then it will always be given by P A intersection B upon PB. So here PB is something which we already know is the outcome, which is an even number, which is 2, 4, 6, and this is the sample space. Now I want to find out what is the probability that the outcome is 2. Alright, so PA intersection B is going to be just 1. Alright, because there are 3 outcomes which I know, out of which only one is my requirement, right? This is the favorable outcome which I have. So this is going to be 1 PA intersection B because there is just one element 2, and PB is all the elements which are there in the outcome. Since I already know that the outcome is an even number, it is going to be 2, 4, 6, which is 3. So this is the probability of getting an outcome 2 once you roll a dice, given that you already know that the outcome is an even number. Let's come to this. As far as this question is concerned, it's given that there are 3 urns and each one of them have different number of balls. The first one has 5 red balls, 5 black balls. The second one 4 red, 8 black. The third one 3 red, 6 black. Now one urn is chosen at random. Randomly मैंने कोई भी एक urn choose कर लिया and उससे मैंने एक ball निकाला. Suppose if I choose this urn, I am taking a ball out, or if I am choosing this urn, I am taking a ball out, or if I am choosing this urn, I am choosing a ball. Alright, now it has been given to us that the color is black. This is the outcome which we already know. Now they want to find out the probability that it has been drawn out from this urn. Alright, let's say that the let's say the event wherein the first urn is chosen is E1, the event in which the second urn is chosen is E2, and the event in which a third urn is chosen is E3. Alright, and the event of drawing a black ball be given by A. Alright, now let's see this with the help of a tree diagram first. So the probability of choosing each of the 3 urns is equally divided, right? So the probability of choosing the first urn is 1/3. The probability of choosing the second urn is 1/3. Also, the probability of choosing a third urn is 1/3. Right? Now, once I have chosen the first urn, this is a tree diagram, so we will follow a tree structure. Once the first urn is chosen, then the probability of getting a red ball out of it will be, since there are 5 red and 5 black balls, is going to be 5 upon 10. That in urn 2, for the same event, it is going to be, for the black ball, 8 upon 12, since there are 8 black balls. For the third urn, it is going to be 6 upon 9, since there are 6 black balls. Now, this is the tree diagram which I have drawn. Now, here I list the events. The first event is the first urn being chosen and a black ball being drawn out. Alright, the probability of which is going to be this into this, because this and this, so for and we use multiplication, so 1/3 upon 5 by 10 is given by 1/3 into 1 by 2 is given by 1 upon 6. Similarly, this event is E2 intersection A, which is going to be 2 upon 9. This is going to be E3 intersection A, which is going to be again 2 by 9. So if you do the sum of all these probabilities, it is going to be 11 upon 18, which is the probability of getting a black ball. Now, the required probability is that the probability of getting it from the third urn and a black ball, given that black ball has already been taken out. We already know the outcome. Now it is going to be given by what is the value of this? It's already been taken out. It's 2 upon 9. What's the value of this? It's already been taken out. It's 11 upon 18, which ultimately gives me the answer 4 upon 11, and this is the answer. Alright. Similarly, if the same thing is being done normally, then if I take A being the event of a black ball being drawn and EI be the event of ith urn being chosen, where I is 1, 2, 3. Alright. So the probability of choosing the first urn is going to be 1/3, as we discussed. The probability of choosing the second urn is again going to be 1/3, and the probability of choosing the third urn is again going to be 1/3, as they are equally probable. Now, after choosing the first urn, what is the probability of getting a black ball? Since the event is indicated by A, I will try to find out probability of choosing a black ball given that the first urn has been chosen. So it will be given by 5 upon 10, which we saw over here, that there are 5 black balls and 5 red balls. So the probability of choosing a black ball given that the first urn is chosen. Alright, this is again a conditional probability. The probability of choosing a black ball given the second urn is chosen is again 8 upon 12. For the third one, it is again 6 upon 9. Alright. Now, if we apply Bayes' theorem, which we saw over here, then the probability of the probability that it has been drawn from the third urn. So the probability of drawing it from the third urn, given that the ball is black, given that the color of the ball is black, is indicated by this, which is going to be given by this thing, because this is what we are interested in, that I'm getting a black ball out of the third urn. So it's going to be 6 upon 9, alright, which is going to get divided so this is going to be that firstly the third urn is being chosen, which is given by 1/3, and followed with what is the probability of drawing a black ball out of the third urn. It is 6 upon 9 divided by 1/3 of 6 by 9 plus 1/3 of 5 by 9 plus 1/3 5 by 10 and 1/3 of 8 upon 12. So this is being chosen, multiplied with this is being taken out. This is being chosen, multiplied with this is being taken out, plus this is being chosen and this is being taken out. So once we write it like this, the answer is going to be 4 upon 11, which is your answer. Thank you.